All right, so we are here about to do our last review for our test 2 for our geometry test. Okay, this is a sample 2 to complement the sample 1 that is given to you in your blank class notes, right? Here is sample 2, some problems that you're going to encounter on the test. Again, it's going to be random, and it's some problems that you have seen and probably has been noted, of course, in your notes that you need to make sure you know how to do. So we're going to see some ones, especially the Ladybug racetrack problem. Now, they told you in the notes to do it. I know your teacher told you to do it. Here it is on your sample. It was on sample 1. Here it is on sample 2. That means it is going to be on the test. So make sure, know how to do it. And we're going to do it tonight, okay? To make sure when you see it on the test, problem number 7, I don't know where it's going to pop up, but it's going to be there, okay? Make sure you know how to do it. Here we go. We're looking at our first couple of problems where we are looking at some conversions. Now remember, you have to memorize these things. And we have some US conversions and our metric conversions. And our US conversions, we only had 3 that we had to memorize so that we can do our simple conversions going on here. Let's go ahead and take a couple of minutes and do numbers 1 and number 2 where we are doing our conversions. Try not to look at your notes if you can help it. But if you got to peek, go ahead and peek, okay? All right, but try not to. Let's see if we can recall it and what we need to do in order to convert from one measure to another. Make sure you're paying attention to what they're giving you. Taking a couple of minutes to look at it. All right. Making sure we're reading that they only want, all right, the final answer, yes, but they want it as a reduced fraction, no mixed numbers, all right, and no calculator approximations. Working on number 1 and number 2. Okay. Think about it now. Okay, Dominique, you have a question?
Yes, ma'am. Good afternoon.
Hi.
I have the whole packet, and I don't see sample 2 in their review. I see sample 1 review. Is
That
sample
is
2
correct.
not in there?
Correct. It is not
Okay,
in there.
okay, because I
Yeah,
was looking for it. I have all these papers. I'm like, it's not here. Okay, so it's not there. So I have to
correct.
here. Okay,
Yes.
thank
This is
you.
this is the special sample.
Yes, ma'am. Thank
Yeah,
you.
you're welcome. Mhm. All right. Mhm. Okay. Mm. All right, we should be almost there. Remember now, when you're doing your review and you're working at home now, make sure you're testing yourself, okay? Make sure you're doing that. Write down a couple of problems. Give yourself 2 minutes each problem, okay? You can write down a couple of conversions and that will work as one problem, right? Making sure you test yourself to get that testing, anxiety under control. And also it's a study tool as well, because then you're also forcing your brain to remember some things, okay? You test yourself, make sure you don't look at your notes, see what you know, and then go back and check yourself because you already have the answers, okay? You can do it with your homework problems that you've already completed. You can do it with your test review because you already have the answer key, all right? So you have your backup now. Okay. Going to be talking about it in just a couple of more minutes now. Just give it a try. You want to get it wrong here, not on the test. Okay. Okay, we're about ready to start looking at it. All right, some thumbs up to let me know. Are we ready or we need more time? Okay, all right, good.
Sandra says she needs a few more minutes.
Okay.
Wendell says he needs some help with the conversion.
Okay, we're going to talk about that goodness. All right. Go ahead and take a sneaky peek at your conversions if you have your notes. All right. All right. This is a really important part. We want to spend just a little extra time on it because if we don't know how to do our conversions, when we get to our problems where we actually have to do some conversions inside of them, then we won't get it right. Okay, no matter how we pick the right formula to use, no matter how much we do the right multiplication and division in there, if the conversions aren't right, then it's no go. Okay, so we got to make sure we're okay with the conversions part. Okay. All right. All right, let's go ahead and start talking about it. All right, so now here's what's going to happen. When you get to the test and you get this problem, now if this is your lead off problem, whenever you get to it, on your scratch paper, you should do a purge, okay? Purge your mind. Even when you get there with the purge, go ahead and get it all out. You need to know the conversions. You already know, you got to know. So go ahead and get them out so you don't have to think about it. Go ahead and tell me what my US conversions are. What do I need to remember?
There's 12 inches in 1 foot for the first
Okay.
one.
12 inches equals 1 foot. What else do I need to remember?
3 feet equals 1 yard.
Okay, 3 feet equals 1 yard. Uh-huh.
There's 5,280 feet in 1 mile.
5,280 feet equals 1 mile. That's what we got to remember. Okay. So go ahead and just get them out of the way. So now that we have them written off to the side, now we're ready to see how we're going to use them. And so for the first one, we're going from feet to inches. And we have a direct conversion right there, as they indicated right here, this first one. So start with what they give you, 17 feet. So you have 17 feet, put it over 1, okay? And we're going to multiply it by our conversion fraction, writing this as a conversion. We have to make sure we cancel out the feet so that we're left with inches. So to make sure that our conversion fraction is oriented correctly, the feet have to go in the denominator so that when we multiply them, they can cancel out. So the feet are here, our inches are going to be here at the top. So we have 12 inches to 1 foot. Is everybody all right?
Yep.
Okay, so now we're ready to go ahead and multiply. I'm gonna go ahead and do my cancellation of my dimensions so I can get them out of the way. And I can't cancel out any numbers. So now that leaves me 17 times 12. And that's going to give me my total inches. What's 17 times 12? What does that leave me?
204.
204. So 204 inches. Is everybody all right with that?
Yep.
Yep.
Okay, just remember, you have to cancel out your dimensions that you're starting out with so you can end up with what you're looking for. Okay. Now we have yards to miles. Do we have a direct conversion from yards to miles?
No.
No, we don't. But we do have yards to feet, and then from feet to miles. So now we have 2 conversions we got to go. Here we go. So we have 52 yards. Start there. Over 1 times. Give me my first conversion. Where do my yards have to go?
On the bottom.
On the bottom, because they got to cross out. And then my feet are going to go to the top because I know I have to go there first. So I have 3 feet to 1 yard. But now I got to get from feet to miles. I need my second conversion. Okay. All right, so my second conversion looks like what?
Be in the denominator.
Beautiful. My feet. How many feet are going to be down there?
5280.
Beautiful. All over that 1 mile. Is everybody all right with this setup so far?
Yes.
All right, now let's go ahead and get to canceling some stuff. We can cancel these yards here. We're canceling the feet. We're on the right track. All right, so the only dimensions we have left is miles. All right, that's good. Now, if you wanted to go ahead and cancel out some numbers, that's great. If you want to just go ahead and multiply across, multiply the top 52 times 3, get your number, all divided by 5280, and then put that in your calculator. Okay, that's what your calculator is for. Then you can simplify your expression. So in your calculator, remember, a lot of our calculators will do a lot of this. So on the top, we have 52 times our 3 gives us
156.
okay, did everybody get that number right there? all over 5280. So we're going to divide by that. And we get this funky looking decimal. Did you get a funky decimal?
Yeah.
Okay. Now we cannot put approximations in here, but they want a reduced fraction. So what you want to do is go to your F to D button. So if you have a scientific calculator, you have an F to D button. If you have the TI-30XS calculator, all right, then you probably have a toggle button that looks like this. Looks like a little arrowhead, right? Like opposite of each other. It's right up above your equal sign, your enter button. All right. You got that? You push that button and it will toggle back and forth to reduce your fraction. But you're looking for your F to D. Some of you may have a S to D, right? If you have a graphing calculator, then you have a math button at the top left. Push your math button, and the first selection should be FRAC for fraction. Then it's already highlighted. Push enter twice, and it will write that funky decimal into a reduced fraction. All right. Do we have our reduced fraction? All right, Sierra, what kind of fraction calculator do you have?
It's the one you just mentioned, the TI-30X.
TI-30X. So in your in the middle, I believe in the top middle of your calculator, do you have, what color second button do you have? What color is it?
It's blue.
Blue. Okay, so in the top middle of your calculator, do you not see one of these F to D buttons?
F to D.
Mhm.
Oh no, I see it now. Yeah.
Mhm.
Sorry.
Okay. All right, Wendell, go ahead.
Yeah, I have the decimal, but when I push that F to D button, it just has MPR, NCR, and then has an exclamation point. So
You have to push the second button. If the F to D should be in a color, so you have to push that second button that's in that same color.
Okay, so we're pushing the second button before we're pushing the F to D.
Correct.
Okay, yes, ma'am.
Right.
Sorry.
Yes. Remember, your calculator is color coded. So whatever you're trying to get, if it's in that color, you have to push that second button at the top left of your calculator in order to get that thing.
So I did the second, and then I did F to D. What do I press after that? So when I press equal, it just takes me back to the.
You could press some calculators. You have to push the enter or your equal button. Yes.
It still gives me the decimal. I have the same calculator that you mentioned.
So it's supposed to be 13 over 440?
13 over 440.
Okay.
Okay, somebody said that it still gives you the decimal.
Yeah, it's doing it to me.
Okay, and what calculator do you have?
The TI-30XS.
Okay, so do you see your F? You said you have the F to D button.
Yeah, I have the F to D button. I push second before pressing it, and it shows up as like the decimal, the 0.0295, and then it just says F to D next to it. And then when I press enter, it gives me the decimal again.
You have to press enter again. I had to press enter again.
You have to press, yeah.
Still not doing it.
I did it upside down, and I ended up putting the 5,000 first instead of the 156. I was like, that's not good.
Oh, no, okay. All right. Malia, I think I said your name right. I hope I didn't butcher it.
I have a graphing calculator. Can you tell me how to do it on there again?
Push the math button. It's the first selection.
Okay, thank you.
You're welcome. All right. I would have to, I'm not sure why it's not giving you, do you have this button right here with the two arrowheads pointed against each other? Down to the
What is
bottom right?
No,
You don't? Okay.
I don't think so.
Well, you'll see it. It's right next to your enter button. It's right up above it.
No, I have a plus sign above my enter.
Okay. All right. So clear out and try putting your fraction in again. It might be that it got confused. Sometimes that will happen. And see what happens. Okay. But it should give you that reduced fraction of 13 over 440. Is everybody else getting the 13 over 440?
Yes.
Yes.
Yeah.
Okay. Is anyone's calculator giving them a mixed fraction of some sort or some other form of the answer?
Hey, come on, man. Hey, now you hold it by the.
Huh? What happened? All right. Is it working? Trying to make sure that we're getting it. Good. Okay. All right. All right. Let's try our next one. We see we're going from miles to inches. Go ahead and do your relay. All right. So we're starting with 4 miles. So we got 4 miles all over 1. And so my first conversion fraction, we know we're going to do miles on the bottom. So we have 5,280 miles over, not
One.
miles. Y'all saw what I did, right? Y'all was going to correct me, right?
Yes.
All right, 1 mile all over 5,280. Okay. Now where am I going?
Feet to inches.
Okay. So we have 1 foot so that it can cross out. Remember, always
Yep.
look at the diagonal and then going to 12 inches. So remember, we want to end up with our goal. Okay. Now we're ready to cancel. So we have here, 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 and here. And we can't cancel any numbers because we just got 1 down there. So we're just multiplying across on this one.
Mhm.
Okay. So we have,
200.
what do we get? 253,000, I heard.
440.
Yes. 253,000. 440. Yep. Everybody got that big number?
Yep.
Okay. Now, remember, think about what you're doing. So if you're going from miles to inches, your answer can't be 7, right? It can't be 20, right? You should have a fairly nice sized number because you're going from miles to inches, and you should have a lot of inches in miles. You should have a lot of feet in miles. Is everybody okay?
Right.
Right. Think about it logically, and that's going to be your self-check. for your answer. All right, let's look at number 2. We're looking at the metric conversions. So the metric system. So now tell me what you need to remember about the metric system, the expansion. This is another perch where we got to write it out because we got to do this for each one of our problems so we can see where we're going. Tell me what it looks like when we expand it out. What does it look like? What's the first thing I need to write?
K, K,
Okay, and then
H, D,
just D.
DF,
Okay. And then just a little line in there, right?
right.
Okay, and then what comes next?
Then M,
Okay, just, is there M next?
D.
Okay, just D. Okay,
E.
C, and then MM.
okay, you got C, and then you have M.
MM.
Okay, so we have to remember K, H, D, A. Then remember there's a D on the other end of our line, right? Space, and then another D. Then we have our C and our M. So King Henry died while drinking chocolate milk, right? Or however you remember it, whatever mnemonic you came up with, or whatever is in your spirit, however you remember it, remember, say it, because you're going to write it every time. So now when you're doing your conversions, you're going to write it, and then you're going to again look at what they're giving you to see if you can even do it. Can we convert this first one?
Yeah, the first one.
Mm-hmm.
Yeah.
We can, right? Because we're going from
From
L to
the-
L. Right. Okay, so we can do it. So we have L, 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 right?
Right.
Here's L. We plug in our L there. All right. So we're starting right here, and we're going all the way over here. Okay. So start and then end. Tell me what my answer looks like.
0.004.
Okay, so 0.004. Is everybody okay with that?
0.0004. 3 zeros.
No, it should just be 2 zeros because you got to move the
Okay.
decimal point past the 4.
Oh.
Right. So when we write it, you have 4, but the point is right here behind it. So 1, 2, 3. Right. So 1, 2, 3. This is my new decimal point, and then you add your 2 zeros. Make sense?
Yeah.
Yeah. Okay. All right. What about our second one? Can we do it?
Yeah, they're the same.
Yep. M to M.
Yes.
Okay. We're going from KM to DM. All right. Tell me what my answer looks like.
It'll just be 9,000, wouldn't it?
9,000. Y'all are on it. All right. We're just moving that decimal point in a direction, however many times it takes us to get to the next point. We started here at KM and we moved it 1, 2, 3, 4 places to the right. Here's my decimal point right before the 9. 1, 2, 3, 4 will give me 9,000. Is everybody okay?
Right.
Okay. What about my last one?
No, you can't convert it.
Can't convert it. You got going from M to G. Can't do it. Okay. Can't do it. So don't try to do it.
So
Is
quick
there-
question. Is it when that pops up on the test, how do you enter it? Because can you enter it in letter form? Can't do it, or?
You're gonna enter it how they ask you to enter it. They might
D&E?
say,
Okay, thank you.
they might say D&E. They might say can't give you the option of doing it. Follow their instructions, okay? And they're gonna tell you how to do it. Is everybody all right?
Right.
Yeah.
For the second one, why did you move it over 4 again?
We started at KM and we were going to DM.
Okay.
Right. So that was 4 places to the right.
And then the first one, why was it to the 4 to the left?
Again, we started at CL and we went to DAL. You're just going in a direction.
Okay.
Mm-hmm. Any other questions? All right, let's move on. We spent a good bit of time on that. Now we gotta pick it up. Now, what are we gonna do? We're moving to looking at some perimeter, some angles, remembering some stuff. Go ahead and look at number 3 and number 4. All right. See if we can come from the words to the setup. That's going to be important. Remember, just like in the homework, sometimes they're going to give you a picture. Sometimes it's going to give you words. Sometimes they're going to give you pictures and words. Okay. But we got to be able to interpret whatever they give us. Okay. Think about what they're asking.
While they're calculating, I still have a few people that need to put their name in the chat for the records, please. Right. Making sure that we're okay with the setup. If there's a hard part coming from the words to the setup of the pictures, that's going to be the hardest part. Okay. It says a ladybug crawls around the outside of a rectangle that measures 10 centimeters by 20 centimeters. My well-trained ladybug stays exactly 2 centimeters from the edge of the rectangle at all times to form a larger rectangle figure. All right, so they didn't give us a picture, so it means that we need to draw our own picture, and they're telling us that it's a rectangle. Okay, so we know that shape. So here we are with some rectangle figure. All right. And it says that it is 10 centimeters by 20 centimeters. So one thing we definitely have to make sure, every time we're going to do something, always make sure you check the dimensions, right? Because if you have to do some conversions, you need to go ahead and should do it right up from the jump. Okay, that's the best way to not have to worry about doing getting anything incorrect. So we're glad that to see that everything is in the same dimensions. Everything is centimeters. So we're good. So we have 20 centimeters by 10 centimeters. Okay, I'm gonna change my color here so we can see some contrast and stuff going on. Now it says my well-trained ladybug stays exactly 2 centimeters from the edge of the rectangle.
So now we got this ladybug traveling on the outside of this rectangle, 2 centimeters from it. So here is, right, this ladybug. And she's well trained, making this path around this rectangle, okay? Staying approximately 2 centimeters, okay, around this rectangle. So this is arrow right here. Well, that ugly one that I was just trying to draw right there. So this right here is 2 centimeters, okay, all the way around. But now think about what that means for these dimensions. What they want us to do is, how far does the ladybug crawl in one trip around the figure? Around something. What are they asking us for?
The perimeter.
Perimeter.
The perimeter. Okay. So perimeter. I need some new dimensions now. Tell me the length of the side of this new rectangle right here. What is this length right here now?
22.
22.
Are you sure? Look at it again.
Oh, 12.
Mm,
No?
no, not 12.
18.
Oh, okay, hold on.
What
Now
was the
don't-
question again, Professor?
What is the length of this side of the new rectangle?
Is it 18?
I was
No.
thinking it was 20 centimeters.
24.
No, it's 24.
24, because it's 2, 2.
Look at what's going on now. We just drew this bigger triangle that's 2 centimeters from the original.
Yep.
So that means that this 2 centimeters more this way, right? And 2 centimeters this way, right? So that means that this new side right here has to be 20 plus 2 plus the 2 over here makes 24. Do y'all see that?
Yeah.
Yes.
Okay. So then tell me what this new side over here is.
14.
14.
Any questions about it? Once we got this, now we know what's going on. So if we know what we're talking about the perimeter here, so now tell me what the perimeter is with the correct units now.
76 centimeters square.
Okay, so we got 76 centimeters, and you said squared?
It will be cube, right? Because it's 3.
No.
No. Is it the square?
No.
No, it's just straight.
No. If I'm putting a fence up around something, do I need to take action on the centimeters, on the measure, on the units?
Just
No, just centimeters,
Just centimeters.
because we're not looking for area.
That's right. Okay.
Excuse
So,
me.
it's just centimeters. When you're going around something, putting a fence up, okay, you don't take action on your dimensions. All right, so perimeter, no action.
Right.
Okay, now it says, what is the area?
Excuse me. I have one question.
Sure.
So how did you get the 76? I see how you got the 24 and the 14. And then what did you add together, multiply together to get 76 for the first one?
Well, if we're looking for perimeter says
2 times length plus 2 times width.
add up all the sides.
Add up all the sides, right?
Oh, okay. I was forgetting a side. I know exactly what I did. Okay. Thank you.
Uh-huh. And we got 14. I just saw your question, thank you. We got 14 because this is 2 inches here. And this is 2 inches here. So 10 plus 2 plus 2 gives me 14. Is everybody clear on how we got the sides now?
Yeah.
Okay, very good. All right. So now we're looking at area. Give me the formula for the area of a rectangle.
One half times one half times base times height.
Length times width.
Length times width.
Okay, it's just length times width. Okay, 1/2 base times height is for a triangle.
You're right.
Right, okay. So, but we won't have to worry about it because we're gonna have our formula sheet on the test. All right. And so, all right, we'll have the formula sheet. And then you'll see that it's length times width. And so when we're looking at our area, so now we're gonna put carpet down, right? So we talking about inside stuff. Now we're about to do something. So now we have 24 times 14, and that gives us what?
336.
6.
All right. So
386.
and 36
square centimeters.
Square.
There you go. Now we're going to take action on those dimensions. Okay, so remember, perimeter, no action. Area, square. Okay. Is everybody all right?
Right.
Okay. Number 4, give each of the following types of angles. Describe the measure of each. All right, so this might come in a paragraph form on the test, and all you have to do is fill in the numbers. Tell me the numbers of, or the angles for which an obtuse angle lies between. Between what?
0 between 90.
No, for
No,
obtuse.
no, that's okay. Okay, 90
between 180.
All right, so between 90 degrees, right, and 180. Don't change any of the numbers. Right? Between 90 and 180. Acute is between
0
to
90.
Good. Okay. So between 0 degrees and 90 degrees. What about that right one?
Exactly
90
degrees.
Okay, so exactly. Now, when you see this, make sure you just fill in the blanks with the right numbers, and you should be fine. Is everybody all right?
Right.
Okay, don't change any numbers. Okay, Wendell, go ahead.
What is that again? I can't see the obtuse. What number does what is the
90 to 180.
90 to 180.
Mm-hmm. 90 to 180.
I didn't get the other two neither. I was trying to grab them.
The other one, acute, is 0 to 90. And we know right triangle is exactly 90. Oh, there it is. I'm trying to get back to number 5 for you. There it is. All right. There's number 5. Read it carefully. We should have our possible results.
BAC.
Okay, what are we getting?
Will it be E to E to D over B to A
No, they gave you some information on the sides.
on the sides, okay.
Okay, so use their information.
$88.36,85801.
No,
B to F.
all right. Anybody else? Come on.
I got 707.3.
No,
Says do not solve.
y'all aren't reading the directions.
It says do not solve.
Yeah, it clearly says that in bold, and they capitalized it for you and everything.
So
Y'all still don't want to read it.
D to F.
All right, Deborah, not quite. You're missing some parts and your orientation is kind of off. Try one more time.
Is it BC over EF?
You shouldn't be using any letters. You should be using the numbers that they give you and the information.
X plus 117 equals to 250 over 331.
Okay, say it one more time.
Well, X over 117 equals to 250 over 331.
Okay, that's a good setup. Okay, I agree with that. As long as you're consistent, starting with your first fraction. She started with the second triangle down here. She said X over 117 equals, it is an equation, right?
Right.
Equals, and then she came back to this second triangle and with 250 over its similar side, 331. That is a good setup. Anybody have anything else that they did?
That's the answer?
Yes, that's one of the answers.
Because I have 250 over, yeah, that number, not the same one.
You got the same thing?
Yeah. I have I have 117 over X equals 331 over 250.
That's a good setup. Okay. So if you went from the first triangle to the second triangle, that's fine. So if you had 117 over X equals, and then came back and got 331 all over 250, that's a good one. How about nobody did X over 250 equals 117 all over 331.
I didn't know that was one that can be done.
As long as you are consistent, you can do that. You sure can. You can go backwards with that as well. There are a lot of possible results for this problem. They simply ask you to solve up, set up an equation that you would need to solve. Is everybody okay? Just be consistent, okay? Now, let's put it in action. Number 6. Let's do it for real now. There's your problem. Remember, if you can't see what they're asking you for, break it up so you can see it. Okay, don't sit there and look at it and think it's going to just by osmosis jump on you. Okay, break it up into 2 pictures. If they give you a picture that's joined, break it up into 2 pictures. Just make sure you label it correctly. That's the key. Okay, make sure you label it correctly. Okay. Should be almost there with it. Huh? Okay, we got a possible on the floor. All right. Looking good. All right. Mhm. But when you break it up, you'll see what you really have. Mhm. It's really hard to see it when it's all combined.
Two triangles definitely make this one easier to see.
Yes, it does. Mhm.
I guess because we've been so used to them being broken up, so instead of being stacked on top of each other.
Yes.
It reminds me of those memes, like how many triangles do you really see in this picture though?
Yeah, it's true. All right. Let's go ahead and we're about to see if we're breaking it up correctly. All right. We see that we have the two triangles, so we should have a larger one and a smaller one. Now, it's not rocket science, so don't beat yourself up if it's not a pretty triangle. Okay, you just want a representation of what's happening. So we have a big triangle and a smaller triangle, right? They just need to be similar. Okay, now we're going to label them. So remember, here's our A, our B, and our C for the big triangle. And then for the smaller one, we have an A, a D, and an E, right? Now let's put our numbers on there. So for the big one, we have 70 there. And they want us to find AC. So AC is right here. Let's just call that X. Okay. Right. And then we have on the smaller one, we have our 7 here and a 4 there. Okay. So now we've labeled. Now we need to set up our equation, right? Our ratio so that we can solve. Okay, give me a ratio. Go ahead, tell me what you set up.
70 over 7 times 4 over x.
Okay, 70 over 7. Is it times?
Equals.
Okay, so make sure we put an equal sign and not a times. So 70 over 7 equals x over 4. So remember, you're going in the same direction each time. So if you started here and with here, you have to equal starting back at the big triangle, going to the little triangle. You got to be consistent with that. Is everybody okay with this setup?
Can I give you one tip also that I found that helps?
Sure.
If you put 70, you might want to put the word big beside the 70 and the word little besides the 7. And then on the other side, you know, you can remember to put the big on top and the little on bottom.
That's a good one. Mm-hmm. Yeah. Is everybody okay with that?
Yep.
Yeah.
Yes.
That's good. All right. So now, okay, now let's go ahead and do our math. We're cross multiplying now. So now we're actually finding the side now. So we're cross multiplying. So we have 7x equals what?
280.
Then we're going to divide. How many times does 7 go into 280?
40.
40.
40. So we have x equals 40. Any questions about it? All right, are we good? Yep. Good. All right. Here's number 7. They want the circumference and the area. If anybody needs to see the formula sheet, let me know, and I'll switch to it. Is everybody okay with the formula? Okay, all right. If you have your formula sheet with you, that's great. You're looking at it. Make sure you're reading the directions. Okay. Okay, so, all right. Deborah, I'm assuming that the first one is circumference and the other one is, like, tell me which one is which. Okay, yeah. When you put your answer, put C equal or A equals the, yeah, so we can know. There you go. Okay. And all right, Deborah, go back and kind of check. All right. And also make sure you put the dimensions in there too. All right. So when you put your answer in, give me the dimensions. All right. Get the dimensions. So our formula is, we have 2 for circumference, remember that. So they gave us a diameter here. So let's use pi d for that one, okay? And then area is pi r squared. Okay. Okay. Ms. Lily, all right. Okay, Deborah, again, go back and check which one you're labeling. Okay. All right, we should be there. Not much work. The beauty of in terms of pi really helps us out. Okay, it really, really helps us out because it makes it where it's not that much, okay, work going on. Okay. Wonderful. Starting to look good. All right. Okay. Good, good. All right. All right, let's go ahead and take a look. All right. So for the circumference, we need a diameter. So remember, when you're looking at using a formula, get your formula and then check to see if you have all the pieces you need to use the formula. So for the circumference, we have pi times d. Do we have a diameter? And they gave us one right here. 12. Okay, so we're just plugging that in. So pi times 12. Okay, and then they gave us meters. Remember, circumference is the same as perimeter, and we know that we don't take any action there. So our answer in terms of pi, and remember, in terms of pi means don't take any action on the pi. It stays in your answer. So we have 12 pi meters. Okay, simple as that. So 12 pi, and
If we
then
did solve it and put the solved version, would that be wrong?
yes, if they didn't want that, it would be wrong. Okay, if they ask you to round it to a certain number, then you give them that. You give them the decimal number. Okay, but if they don't ask for it, then yes, it would be wrong. All right, the area is here, pi, but now we need a radius. What's my radius?
6.
6. So remember, cutting this in half. So radius equals 12 divided by 2. That gives us 6. So now we have 6 that I have to square. And then it's meters that you also need to square. Okay, so then we have 6 squared gives us 36. Here's my pi, and then meters squared. So area, 36 pi, and then meters squared. Are we okay?
Yes, ma'am. Got it.
All right. So again, perimeter or circumference, don't touch the dimensions. If you see anything that says area, dimensions are squared. Okay, every single time. All right, here's number 8. They're asking us some specific stuff. Make sure you read again in terms of pi. All right, but looking at what they give you now. Get the structure. It's always good to fill in something, okay? But you got to figure out what you're doing. Think about it. Think about it. Talk about it in 30 seconds. You can understand the overall concept of what you're doing, then you can work the problem. All right. Okay. Make sure we're thinking about it right. Because if we ain't thinking about it right, it won't work. Step 1. I need the structure of what I'm doing. Okay. What do I need to do to solve this problem? Think about it generally. What do I need to do to solve for the area of the shaded region? So I need the area of the shade. What do I need to do?
Do half of
Find the area. Find the area of the square and the circle.
But what do I need to do with them?
And then add them together to find the shaded. No, subtract them from each other.
Okay, so which one am I subtracting from where?
Subtract the area,
You're subtracting the shaded region, so like the circle from the square.
Okay, so we need to find the area of the square, right?
Right.
And subtract the area
of the
circle from it. Everybody all right with that?
Yep.
Okay, this is my structure right here. I need the area of a square minus the area of the circle. Is everybody okay?
Is this being recorded?
Yes.
I need to look at this later. Oh, golly. Okay.
All right. So now that we know what our structure is, now we need formulas. So step 2, I need the formulas to support it. All right. So the formulas, we need the area for a square and the area for a circle.
I think the formula for the square is A2.
No.
Length square.
So just length times width, right? It's kind of the same as a rectangle. Okay, so we use that same one. So length times width minus the area of a circle. And we just looked at that one, right?
Right.
So the area of a circle was
higher square.
Are we still all right?
Yep.
Now my third step. Do we have all the parts we need to use the formula? Okay, so all right, find missing parts and then plug it in if we after we finish finding them, plug them in. Do we have a length and the width?
120.
No.
Well, we do. They
No.
told us the
We
diameter.
have 120.
Right? The diameter,
Okay.
right, is 120 centimeters, right?
Right.
So if it's a square, then we know that we have a length and a width, and it's 120. So 120 times 120. We got that. We agree with that.
Right.
Minus. Now, do we have a radius?
Yeah.
60. 60.
Okay, it will be. So the radius equals 120 divided by 2, which is 60. So we have pi, and then here we have 60 that we have to square. Now, step 4, solve it. Okay, now comes the magic. Do your thing. You know what you gotta do.
Got about 13 minutes left.
Yeah. Okay, we're ready for our answer. We know what we're getting right here, 120 times 120. You got a big number, what is it?
14,400.
Okay, you should have gotten 14,400. Everybody got that? Okay. 14,400.
Oh, okay. Oh, yeah.
You got, okay, good. Minus 60 squared gives you what?
600.
Mm-hmm. And then your pi. Okay. Can we combine these two terms?
No, because you say in terms of pi.
That's right. And these are not like terms. Okay. So our area of the shape equals 14,400 minus 3,600 pi. And because both of them have the same dimensions of centimeters, what?
Square.
Square. But say it like you mean it, because you know we're talking about area. Right?
Right.
Yes.
You know it, right? So centimeter squared. You're gonna put parentheses around it and then hold it together and give them both the same dimension of centimeters squared. So we have 14,400 minus 3600 pi in parentheses with centimeters squared as our dimension. Is everybody all right?
Yep, that was hard when I did it on my homework.
Right. And remember, you can't combine unlike terms. Okay, and that pi sign makes them unlike. Okay, it'd be different if you had a pi sign here, you can combine them, but you can't. You're just gonna hold them together with that subtraction sign, put them in parentheses, and put your dimensions on the end. All right. Now let's look at one of these. You're gonna have 3 of these on the test.
No.
Right. Yeah. Remember, we had 2 of them in the lesson, right?
Right.
You're gonna have 3 of them on the test. Okay, so we gotta do it. But look, it's in terms of pi, so that's wonderful, right? Let's work it out. Okay, we see what figures they're giving us. And I'm gonna give you your formulas because we see the structure now. They're asking for the volume. If they're asking for the volume, what is my dimensions gonna be in? Cubed units. All right, so if I'm inches, so it should be inches cubed. So right there, you can go down the test, and once you see these, go ahead and put in your inches cubed or whatever the dimensions are, go ahead and fill that in. You get your 1 point for each one of them. That's 3 points right there, okay? Now you can go back and work the problems. So do you agree that we have these 2 figures that we have to add up in order to get the volume?
Yep.
Yes.
So my structure, the volume equals, I need the volume for, what is this bottom part called?
Cylinder.
Okay, so the volume for a cylinder, or you want to keep it simple, some people call it a can, okay? A cylinder, all right? As long as you match it up with on the formula sheet, you're fine. Plus the volume of, what's this top part up here?
Sphere. Sphere.
All right, a sphere. Some people call it a hemisphere, but you could keep it simple and say a half a sphere, okay? So 1/2 a sphere. Everybody okay with that?
Yep.
Keep it simple. The simpler you keep it, the easier it is to fill in your stuff. All right, so now let's go ahead and here's the formulas. All right, see. Let me show you real quick just to make sure everybody's okay. Your formula sheet, okay, right here. So you're gonna go and toggle between your formula sheet. Here's the formula for your cylinder. Volume equals pi r squared h. You're gonna come down and your sphere is 4/3 pi r cubed. Okay, and then you go back to your test. Remember this, if you're electronic and you're on the computer, you just toggle between the 2 pages, okay? So you pull up your sheet when you need it and then go back to your test. So your cylinder was pi r squared h. Then we're gonna add that to this 1/2. And then I'm gonna put this in brackets here, 4/3 pi r cubed. Those are my formulas. All right. Now we need to make sure we have what we need. Again, my structure, the formulas to support. Now, do I have what I need for the can or the cylinder? Do I have a radius?
Yeah.
Okay. Do I have a height?
Yes.
Yeah. All right. For the sphere, do I have a radius?
Yep.
Yep. Looks like I'm good to go. Now plugging it in. So my radius is 9, and I've got to square it. The height, 15. You see how I have these two fractions here?
Yes.
That gives me the Kabawali's. I don't like it. Okay? You can get rid of them. We're going to do it right now. Can we see that 2 goes into 4 2 times?
Yeah.
I done got rid of this one on the outside. Is everybody all right? Now I'm going to do a rewrite. I got 2/3 here. Pi. Now I'm ready to plug in my radius for my sphere. So my radius is still 9. And I'm raising it to the 3rd power. I can get rid of my brackets and my fraction on the outside just by that one simplification right there. Is everybody okay?
Mhm.
Okay. Now, doing your magic with your calculator. Remember, we're in terms of pi, so we just really need to be concerned with the numbers. 9 squared gives me 81. Do we agree?
Yeah.
What's 81 times 15?
1,250.
Okay, so 81 times 15 should have given you that 1,215. Throw your pi on the end. Plus, you got a fraction here. Remember, if it makes you feel better in your spirit, put the 1 underneath the 9 if it makes you feel better. You just multiplying across if it helps. If you feel good about simplifying a little bit here, do it, okay? So you have 9 raised to the 3rd power, multiply by 2, then divide by 3, okay? There's lots of ways you can put that in your calculator. Go ahead and tell me what you got for your second number, all right? 2/3 times 9 raised to the 3rd power. What did you get?
486 pi. I must have done something wrong.
54 pi.
1,458.
No. 2/3 times 9 raised to the 3rd power.
I'm still getting 486.
What do you put in your calculator? Tell me the steps.
I have a graphing calculator, so I'm
That's
just
fine.
putting 2 divided by 3 times 9 to the 3rd, exactly that, and I'm getting 486.
Yeah, I'm getting 486 too.
2,187.
54 pi.
No. Hold on.
If I cancel 3 and 3 goes.
Let's see. If you put 9, 2, you said 2 divided by 3, because I have 1, 2. And then you multiply, or you could use your parentheses functions, that's fine as well. Okay. You got 4, somebody said 486. But then someone said they got 2,000 something. I heard some other numbers in there though. You should have gotten 486. But I heard some other values that came out. Did everybody get 486?
Yes.
Yeah, okay. So making sure we got that. Okay, I want to make sure that I heard everybody correctly. Go ahead, Deborah, I'm listening. You just put it in your calculator just like you have it written. 2 divided by 3. Just like a regular fraction. Yeah. Yeah, you're welcome. Okay. Now we're going to combine like terms. We can combine these terms. They both have pi, so we can combine them. Okay, so we wouldn't leave them uncombined. So now we have this 486 plus that 1215.
1701.
And okay, and so we get 1701 pi. And then with our dimensions, inches cubed. Okay. So it wasn't too bad, right? Remember, we can combine these. As long as they both have a pi sign, you can combine them. Any questions about it? All right, this is what you're going to do on the test, but you're going to have, again, about 3 of them that you're going to do. So if you can go back in your notes and do the problems that you had in your notes and in that sample 1 test, this is what the other one will look like. It's right from your notes, okay? Then you'll be fine. Then the last parts, okay? In your notes, go back and look at this problem, number 10, okay? It's right from your notes where we were going over how to put your answer in, the exact answer with the simplified radical, the approximate answer, and the approximate answer to the nearest tenth when we're dealing with using the Pythagorean theorem. This is going to be really prevalent. Okay, so I need you to know how to do this problem. Is everybody okay?
Yeah.
All right, so go back and look at that one. That should also be on your first sample in your test packet. I think everybody should feel pretty good with doing this problem. We did this one in the notes as well. All of this should look very familiar to us because we already did it in the notes. So put a star by these right here and go back and look at these and make sure you know how to tackle the area and perimeter of these particular figures. Yeah, we're out of time. I didn't want to hold anybody up. Okay, so that's why I'm going and skipping, right? Yeah, because we're out of time. All right.
I put the link for tutoring in the chat in case
Yes.
somebody needs to come get some more help.
Okay. But make sure you get through that sample 1 that you have in your notes. If you can get through that sample 1, you will be fine on the test. I promise you. Is everybody okay? All
Okay,
right.
question. What's the to pull up the recording of this one? How do we do that? The same way we do if we was in regular class?
This recording will be sent, we'll be sending this out to them, Vera. After we finish, it'll download. We have to give it a chance to download and save. And then what we'll do is if you put your name in the chat, then we'll know who attended.
Okay.
Then we can get it out to you.
Okay, thank you.
Yes.
Thank y'all so much.
Thank you, guys.
And then I also just have one more question.
Sure.
When I tried to just click the link for tutoring, it says when you click, after you like put in your name and your phone number and stuff, and it says, what would you like to get in line for? It says mathematics is closed. Does that just mean for the day? So we should just come back tomorrow and try and go?
It might be because there's a couple people in the queue and they want to make sure that they get help before we do close at 7:30.
Okay, so if I just click that link like tomorrow or something,
Yeah.
it should be able to do the same thing for me.
Definitely.
Okay, thank you so much. I really appreciate everything.
And the other thing I would point out too is in your guys' Canvas shells, there is a link to Smart Thinking, and that is a company that we pay for to provide tutoring for you guys pretty much 24/7. So if you're studying tonight and you want to ask questions, if you click on that link and work through it, you'll be working with a live person also. So you don't necessarily have to just be limited to the hours that we're open here on campus.
Okay, perfect. Thank you so much. I really appreciate it.
Good information. Didn't know it. Thank y'all so much.
You're welcome. Good luck with your test.
Thank you.
Yeah. Did anybody else have any questions?
Thank you.
You're welcome. All right, any other concerns? Thanks, guys. All right, you too.